There's a lot that needs to be taken into consideration when designing a wireless vibration sensor to get the most out of the data that comes from your machine. One of those most important considerations is related to the footprint of the sensor, and that is really denoted as the size of the base that connects to your machine. This could be a magnet, like is shown here, or it could be a stud mount, or it could be another mounting method as per the installation requirements of your sensor. And whenever we talk about footprint, what we really mean is the diameter of the space that's required to install your sensor onto the machine. A lot of machines have been designed to accommodate existing probe type sensors with an ICP on the end of it, and the typical diameter of that sensor is around 25 millimeters. So if your sensor is larger than that, then it can make it difficult to install in those pre-existing situations. Additionally, the path between where the sensor is mounted and where the actual accelerometer or device that reads the vibration signal is mounted is critical. If it's plastic, that could attenuate some of the signal. If it's a steel, mild steel, stainless steel, then that's going to give you the best possible response for higher frequency readings. Where the sensor is actually mounted or located on the device is also very important. You typically want that to be around the center of gravity or center of mass of the device. That means that you're going to get the absolute best response without any harmonics coming in from the actual weight of the sensor. A heavier sensor is going to attenuate some of the signal, it will dampen it, whereas a lighter sensor is going to make sure that you get the absolute best, cleanest signal coming out of your accelerometer. Most vibration sensors also monitor temperature. Temperature is a very critical parameter when it comes to analysing your machines, but what can happen is you get a large lag time between acquiring the measurement and the temperature sensor actually recording that reading that has to travel through all that metal and plastic. So look for sensors that actually have a direct path to the thermistor or whatever device it is that actually reads the temperature data. And of course, whenever you're using your wireless vibration sensor in all different sorts of environments, you're going to want to make sure that it can stand up to everything that the environment has to throw at it. So make considerations for dust, for water, for other particles that might be in the air, oils and things like that, and look out for what's called the IP rating or the ingress protection rating of your device. A higher number on both is a better rating. Lastly, consider the materials that are used to house and protect your sensor. The plastics can create modal frequencies which can give false readings in any vibration signal. So how they're selected, the thickness of the wall, and how that all comes together and is secured together will play a large part in the overall quality of signal that you get out of your sensor.